Hi, Bill, Sally, and Jeff. It's Ganesh again. We're here to once again introduce you to one of the awardees for your Catalyst Fund, your very generous support for our department and some of the trailblazing research our faculty are doing. Once again, I wanted to take an opportunity to first thank you all, both, Bill, Sally, and Jeff, for your extraordinary contribution and generosity to our department, but also take an opportunity to introduce you to some of the beneficiaries of your support and for you to learn a little bit about them and the work that they're doing. So today I'm going to introduce you to Dr. Sethu Pitchiaya. Dr. Pitchiaya joined our department about 4 years ago now?
2 years ago.
2 years ago. Okay,
Yeah.
2 years ago now. Time flies. We're not. But 2 years ago. And okay, so Dr. Pitchiaya, tell us something about yourself.
Yeah, firstly, thanks Bill, Sally, and Jeff for this amazing contribution and helping early career faculty like me jumpstart into a career. I grew up in India, in a coastal city called Chennai, and I took the proverbial boat from Chennai and landed in Ann Arbor after my undergrad, and I did my PhD here.
Great. So when did you get to Ann Arbor? What year?
In 2006.
Okay.
So I did my PhD here. I did my postdoctoral studies here.
What was your PhD in?
My PhD was in chemistry.
Awesome.
Largely doing biochemistry of understanding how small RNAs, especially now in the world of RNA, which recently received the Nobel Prize for actually
the
using
basis of
such
the
RNA
COVID vaccines.
for COVID vaccines. We were studying how small RNAs function inside cells, and that was my PhD thesis. And then I went on to do a postdoctoral work in prostate cancer research.
Right.
And then now I'm here as a faculty in the Department of Urology.
Wow, we're excited to have you, Sethu. So tell us, what kind of work has the generous contribution from Bill, Seth, and Jeff been able to support in your lab? What are you guys doing?
So we have been trying to answer a very, very fundamental question of a very large implication. In a sense, we want to understand how cells of various tissues in our body live or die in response to stress. So we essentially study what can be described as the molecular fight or flight response.
Okay, so you're studying, you're trying to better understand how cells respond to stresses in their environment of whatever type it is.
Or whatever type, drugs it could be psychological, it could be hormonal, it could be mechanical. Any form of stress that comes from the outside, how do cells, respond to it?
Okay.
And they make very fundamental decisions at that point. They either live, they die,
right,
or they thrive.
Okay.
And depending upon these decisions that they make, if they die, that's the hallmark of neurodegeneration. And
for diseases such as?
Like ALS, like
Lou Gehrig's
Huntington's
disease, Huntington's disease, Alzheimer's disease.
Alzheimer's disease, Parkinson's.
Yeah.
And if they thrive, that's the hallmark of cancer, where cells are rapidly proliferating unchecked.
So this kind of work that you're doing, of course, is not only central to urology and urologic diseases, but a wide variety of diseases. Like you said, from neurologic diseases to even cardiac disease to all kinds of diseases.
That is right. And the Catalyst Award has even helped me forge vital collaborations even with people in the department, where we now understand that male infertility is a degenerative disease where cells are dying because of stress. And we have now identified a molecular pathway that may probably lead to it.
Wow, so doing so would hopefully lead to discoveries in therapeutics, identification to improve fertility in patients who are couples that are infertile, but of course in other diseases, as you mentioned, Alzheimer's, ALS, Parkinson's disease, cardiac disease, a variety of diseases. So has anyone ever done this kind of work before?
Seldom done. And this is a novel molecular pathway that we have discovered. So, and the Catalyst Award has been essential for us to even discover this, because it helped us pave the way by developing the technologies to see this process happening in cells.
Wow, so not only have you made fundamental discoveries, you've actually created technologies that has enabled you to study these phenomena.
That's great.
Outstanding. Well, Sethu, we're excited to have you as part of our department. We look forward to sharing your discoveries in person with Bill, Sally, and Jeff at some time in the near future. Once again, you all, thank you so much for your support, for supporting superstars like Sethu Pitchiaya in our department, who I'm confident will someday make a dent in a number of important human diseases. Sethu, thank you.
Thanks, Ganesh, and thanks, donors. Thanks so much.
Hi, Bill, Sally, and Jeff. My name is Jason Keach. I'm the gift officer for Urology. I'm pinch hitting for Ganesh today, who was called off to the OR, which is exactly where he needs to be right now. But I'm really excited to talk today with Dr. Giulia Lane, who's going to share a little bit about her work and how it's being supported by the Catalyst Awards. So, Dr. Lane, would you mind telling us a little bit about what you're up to?
Sure. So first I'd like to say thank you, Mr. and Mrs. Martin and Mr. Capo, for your generous gift to help with our research. A little bit about me: I am Italian American. I moved to the States when I was 3 with my physician parents and come to Michigan by way of Minnesota, where I did my training. I've been here since 2018. I was a fellow here, and I did a research fellowship with a master's in research and a female pelvic medicine and reconstructive surgery surgical fellowship, which means I basically take care of people who have a variety of pelvic floor dysfunction problems, including incontinence. Your generous gift has helped me jumpstart my research career with this Catalyst grant. The research idea is very innovative. It focuses on looking at how the microbiome, which is the bacteria in the urine, and biomarkers, which are different chemicals in the urine, may cause or be linked with overactive bladder, which is a very prevalent condition. This is really exciting work because first, there really hasn't been a lot of research done as far as the microbiome or biomarkers for the urinary tract for this condition. And a lot of that was because up to about 10 years ago, people assumed that the urinary tract was sterile. We now know that the urinary tract has its own microbiome, just like the gut or the skin, and that microbiome might be influencing functional conditions like overactive bladder. What's exciting about this project is that it'll be one of the first to look at how the microbiome changes over time in people with this condition, and comparing that to people who don't have the condition, looking at the differences. And I think it will be the first study to link or look for a link between the microbiome and biomarkers, which are those proteins. So far, as far as an update, we got through the regulatory process and we are recruiting participants. We are about 50% of our goal for urine samples for our control group, and still about 10% for the case group, and that's just because there's more cases we're trying to recruit than controls. So they're about evenly matched. I'm really excited to be using all the tools available at the University of Michigan, so we're recruiting through our UM Health Research Portal, which is a great resource here. We're collaborating with Dr. Pitchiaya's lab to do our biomarkers work, and with our core microbiome team at the university to do the microbiome work. So thank you so much. The project is really off to a great start, and I am excited to have samples to be able to analyze in the near future.
Hi again, Bill, Sally, and Jeff. We're here now with our third and final update for you from Dr. Will Roberts, who's going to talk a little bit about his research and how the Catalyst Awards helped support it. Dr. Roberts?
Yes, well, thank you. And Bill, Sally, and Jeff, the funding you've provided has really been instrumental. It's allowed us in the lab to explore a problem that we see clinically. Ureteroscopy is the most common form of stone treatment, and it requires us to look up into the patient's kidney with the ureteroscope. And we've become more efficient at treating these stones, but we use higher power laser settings than in the past, and that's because of the technology advancement that's really driven the field. We've noticed that amount of energy can really increase the temperature within the kidney. So we've been studying in the lab the effects of that, and concern as that being a source of pain and discomfort and ER visits and complications for patients after ureteroscopy, because there is a fairly high rate of ER visit after ureteroscopy, which we don't fully understand. So in the lab, we've done 2 main experiments looking at this. One was to really quantify at a technical level how much of the energy we deliver is converted to heat and therefore potentially dangerous. And it turns out, using a calorimetric setup, which is like in a chemistry lab, we were able to determine that 95% of the energy we put into the system is converted to heat. and therefore can elevate the fluid temperatures and potentially damage the surrounding tissues. So that was a really important finding, both in the, the mechanism of stone fragmentation, but also how we need to be very careful when we're using these new technologies and make sure we come up with ways to limit the amount of heat that's put into the kidney of any given patient. So that was a really important piece of research that we finished a few months back and was supported by the Catalyst Award. Now, the other area of research was looking at what happens to the tissue in the kidney that's next to the area where the fluid is, where we're treating the stone, and to determine how hot that gets during ureteroscopy, because we weren't sure how well the heat would transmit into the kidney, and is this really a problem we need to be worried about, or is it more just a situation where we're looking at high numbers in the collecting system? And it turns out that the heat does actually transmit. And there are critical parts of the kidney that are really important in filtering the blood and producing urine, and those are called papillae. And they sit right next to the collecting system, and they got very hot. We did studies where we measured the temperature in those tissues when we were doing laser activation, and found that that's a significant area and further reinforces the point that we need to be very judicious about how we deliver this energy. And we're now approaching the envelope of what's safe and starting to define that so we can make ureteroscopy safer for patients in the future. And so we can hopefully then reduce the complications that occur and the discomfort that's felt after ureteroscopy and drives the high rate of hospital revisits. So thank you very much for your funding, and this has led to a bunch of additional hypotheses which we're pursuing at the moment and trying to further expand this area of research.
Fantastic. Again, Jeff, Bill, Sally, thank you so much for your generous support of the Department of Urology at the University of Michigan. We appreciate all that you do to support our faculty and our patients.